Okay, so good morning to all of you, and shortly we are going to start the session of today, right? So just wait for 4 to 5 minutes. I hope it is audible. Is it audible?
Yes, sir.
Okay. Okay, so we are going to start the session. Last time on a lecture of Tuesday, we have discussed about the convolution between two rectangular function. We will continue with some new rectangular function on Wednesday. And now today we will discuss about the convolution function between triangular function and rectangular function. Okay, so be tuned with me, and I'm going to share my screen with you. Okay, hope the screen is visible to you. The screen is visible to you. Okay, is it visible? The screen is visible to you.
Yes, sir.
Okay, okay. So finally, we have two signals are there. One signal is a triangular function, and another signal is a rectangular function. For this triangular function, we have defined the functions for a positive going ramp as well as negative going ramp, and that is consecutively tau and 4 minus tau. And especially for h tau signals, that we can say is a 2, right? This is the 2, amplitude is constant 2 from 0 to 2 value. So now let's again redraw this, whatever the part we have covered so far. Again, I continue with these examples. I hope somebody of you have tried to solve this, and you will succeed to solve this example. But for a revision point of view, let's consider the same example for today's session also to solve. So here it is given that we can have a two signal. One signal is the x of tau signal, which is a triangular function, and this triangular function is basically make it uh, so here we have a triangular function over here, and this triangular function does seem to be vary. This seems to be vary from the two values 0, 2 and 4, and this peak amplitude is 2. This peak amplitude is 2. This signal is x of tau signal. There is another signal which is h of tau signal, and this h of tau signal can be defined as a starting from 0 to 2, and its peak amplitude is 2. This is h of tau signal, and here it is asked to find the convolution between these two signals. Find convolution between x of tau and h of tau. Right? So the first very important part here we need to consider is that we have to identify the exact function of this. So by earlier we have discussed how to find the x of tau function. So there is a positive going ramp signal and there is a negative going ramp signal. So we have already discussed earlier. We can find this function by placing the Starting point is a 0 plus slope multiply by, because it is starting from 0, so it is tau, and this y2 minus y1 divided by x2 minus x1 define the slope. And if you solve this equation, so we are getting this first function for a positive going ramp is tau, and we will find the functions for a negative going ramp which is starting from 2, so it is rather than tau we can have a t tau minus 2. It is again the same equations, so starting point plus slope into tau minus 2. So if you find the slope y3 minus y2 x3 minus x2, where x2 y2 and x3 y3 are corresponding the points of the corresponding points are 2 comma 2 and 4 comma 0. So if you solve this one, then finally we turn out with another function is a 4 minus tau. So this is the function that we basically consider as a 4 minus tau. So now we can say we have two functions are there for this signal. So one function is from 0 to 2, that function is a tau function, and for this negative going slope we have a 4 minus tau. So consecutively, if we write the same thing in a mathematical form, we can say x of tau signal is basically a tau if the tau lies between 0 to 2. But if the same function x of tau can be considered as a 4 minus tau if the tau does lies between 2 to 4. So that way we can define mathematically x of tau function. Same way if we define mathematically of h of tau function, so it is a rectangular function, so we can define by the constant amplitude 2 and the duration is from 0 to 2, and it is 0 elsewhere. We can write it is 0 elsewhere. The same we can write for first function also. So now these two signals are there, and we need to find the convolution function between these two signals. So first things that we are going to start is we find h of minus tau. So here, if we find this h of minus tau, so this signal is considered as a h of minus tau. Here we have not given any value of t, shifting is not applied, so we are assuming that t is equal to a 0. So this point is a minus 2 point. This point is 0, and this point is basically considered as a t point, and this point is considered as a t minus 2 point. This is t minus 2 point, right? And this domain is a domain tau. So now the first portion we are going to start when the t. Okay, so we can write here the region number 1 when the shifting amount is less than 0, means negative shifting. So here we don't require a negative shifting because h of minus tau, the first end of h of minus tau is at on 0, and the signal of x of tau is starting from 0. So if we apply shifting t greater than 0, then overlapping will be start from the first point. So we don't need to shift it left side as we have already done in earlier example. But here we can start where t is less than 0, so we don't have overlapping. So there is no overlapping, and if there is no overlapping, so the convolution function y of t is equal to 0. So we can say y of t is equal to 0 when there is no overlapping, and this is applicable for every t which is less than 0. Now we go for the next region number 2. So for that regions, I will just copy this x of tau and h of tau, and we will find the overlapping area, right? So we will find this overlapping area. So for that one, rather than if I draw the same thing, so we can say we have a signal, this signal x of tau, right? This portion, so this portion is a 0, and this amplitude is a 2, and on that one we can have a this signal. Which signal is this? This signal is h, so amplitude of 2 h of t minus tau. So here you can find this point is a point t, and this point is a point t minus 2, right? And this is 0, and this point is simply defined as 4. And this is it. This is the point at which we have amplitude 2. This is the point which we have amplitude 4. So if this is the region when the t is larger. This is the region we can consider when, this is the region number 2 when t is larger than 0. So you find this is the overlapping area. This is the overlapping area, and in this overlapping area we are interested what is this function over there. So this function is a tau over here, and this function is a 4 minus tau, right? This function is 4 minus tau. So what happens, this rectangular function is combined with the first half part of x of tau signal, where the function which is inclined with the h of t minus tau is the tau, right? So in that case, if we find the y of t, so this overlapping region boundary is actually bounded by the 2 point t, and the second point is a 0, and here the upper bound is a t and lower bound is a 0. So this integration limit is also bounded by this 2 points of overlapping or shaded region, that is 0 and t, and the function which is inside of integration is x of tau into h of t minus tau d tau. Now if we place all this value here, we can see the value of x of tau is a value of 2 here, and h of t minus tau is actually the value mistake x of tau, the value of x of tau is actually the value of a tau, right? This is the function tau in this region, and the value of h of t minus 2, and take the integration one, that integration is equal to the 2 is outside, and if we take the integration of tau d tau, so that is the tau square by 2. This is tau, and if we apply this limit 0 to t, that 2 will be cancelled out, so that left with only the t square is the answer, t square minus 0. But if we remove the 0, then we can have the answer is the 2 square only, and this region will survive till this t is not crossing this 2, because after this 2 then the boundary is going to, function is going to change basically, right? The function is going to change, or is not entering inside. So if the t minus 2 is not entering, is less than 0, this is valid. So it means that t is less than 2. Means if the t is less than 2, then only the first half part is inside the this triangular region, but the second half part of the rectangular function is not entering in the triangular function. So the boundary of the shaded region or overlapping region is not going to change. So this function is survive up to the value of 0 to 2. If the t lies within this range of 0 to 2, this function does survive. This is the reason number 2. Now we go for the reason number 3. So in reason number 3, we will conclude that both the ends of a rectangular functions are inside this triangular function. So if this is our triangular function, this is our triangular function, that is the 0, that is 2, 0 and 4. Then now what happens, this first is already inside this triangular, and second is also inside this. So there may be a scenario where this rectangular function, this end is a t and this end is t minus 2. Both the ends are inside the triangular region. So this now here if we write, so here this triangular is defined as function tau. This one is defined as 4 minus tau. This is the constant amplitude 2. And this signal is basically known as h of t minus tau, and this signal is basically known as x of tau. So now what happens in a region number 3, which does exist when region number 3 is basically exist when the t is larger than 2. What is the upper limit of t, that we will define later stage, but at this point you can consider that t is larger than 2, then we can have a such kind of a scenario. So in this scenario, if you find this overlapping region, so this is a overlapping region, this whole is overlapping region, and if you find the boundary of this overlapping region, so this boundary is defined by this point t, which defines the upper limit and the lower bound of this shadowed region or overlapping region is defined by t minus 2. But now, very importantly, we need to consider here half or maybe sum of the rectangular function is undergone with the value of x of tau as tau function, and another remaining portions of rectangular function is undergo with the different value of x of tau, and that function is 4 minus tau. So some will be combined with the 4 minus tau and some will be combined with tau. How much will be combined with the tau? So the rectangular portion which is below this point 2, which will be combined with the function tau of x of tau, and the portion of h of t minus tau which is larger than 2, it is going to combine with another function of x of tau, and that is 4 minus tau. So that way we can consider the portions below 2 will be go with the tau function, and the function the value of x h of t minus tau which is above 2, it will be undergoes with the values of 4 minus tau. So here we are going to find this region. So that is we may consider the signal is y of t is a 2 this bounding region is a t minus 2, and the upper bound is t, and here we define x of tau h of t minus tau d tau. Now this integration we need to break down in a two part, because the x of tau function is different below the value of 2, and x of tau and differ the value above t is equal to 2. So here this integration is basically breakdown in a two person, t minus 2 to t 2 x of tau into h of t minus tau d tau, and the second half is starting from the point 2 and expanding up to the t, that is the x of t into h of t minus tau d tau. Now we put the two different function here. This function in this portion we will put as a tau, and here we will put this function as a 4 minus tau. So if we put the integration, so we can say t minus 2 to 2 so integration x of tau is the value of x of tau is the tau over here, and h of t minus tau is constant, is showing the constant value of 2 irrespective of the integration limit. So that is multiply with the 2, that is multiply with the 2, and it is d tau, the integration starting from 2 3, and here x of tau is 4 minus tau over here, and this h of t minus tau is even same as a 2. Okay, so now we need to integrate this two functions. So if you integrate this function, the first one 2 tau, so it becomes a 2 tau by 2, and if we apply this limit, so this limit is a t minus 2 to 2, and here this becomes a 4 tau minus tau square by 2, and if we apply this limit here, so that is 2 to t. Now if you apply this limit, so this 2 2 will be cancelled, so it left with the tau square limits are t minus 2 to 2, and here it left with the uh, 4 tau minus tau square by 2 to t. Now if we apply the limits, so that 2 is applied first, so 2 square minus t minus 2 whole square. This is the first integration value, and for second integration value is a 4t minus t square by 2, then 2 is applied, so minus 4 into 2 and plus 2 square by 2. If we solve this integrations and all this value, so that left with the 2 square 4 minus t square minus 2t, so it is plus 2t plus 4, it's minus 4 because minus sign is previous earlier, and here it is the that we are getting here 4t minus t square minus 8 minus plus 2 square by 2, so it is 2, that is 4 minus 4 4 will be cancelled out, so it left with us only the value of minus t square plus 2t, and here we left with this value minus t minus sorry, it's t square by 2, right? So that is the plus 4t minus t square by 2, and here it is a minus 6, right? Okay, so now if we solve this equation for further value, then we can say then this integration will now a what it will be turn out. Identify this one. What it will be turn out. Identify this one. So if you identify this equation, I think there may be some mistake. Okay, we left with this 2. Sorry. So it is multiply here. It is multiply here. It is multiply here. So if you multiply inside, then here we have some different structure is there. This value is 2, so that becomes the 8t minus t square and minus 6, and that is minus 12. Okay, now we have this equation minus t square minus t square, so that becomes a minus 2t square, 2 8 plus 8, so that becomes a 10 8. I mean, so there is again there is some mistake. Yeah, this one is again 40. Sorry, that is the 40. This is the 40. Okay. Okay, so plus 12t, and then this is minus 12. So this is the final answer, minus 2t square plus 12t minus 12. That is the final answer. So this is the case where this region, either this one or this one, is not crossing this boundary, right? Region number 3. So where the region number 3, we can say where this t is larger than the 2, larger than 2, and this t is not crossing this 4, right? Then boundary is going to change. So if the t lies within the range of 2 to 4, this equation does value. This equation does value. So we have this answer. And now finally we go with the region number 5. And in region number 5, we are considering here the thing is this is the signal which is basically from 0 to 4. This is from 0 to 4, and this 2 is, but now this rectangular function is crossing this boundary. The first end is out of this 4, so second end which is only 2 steps away, which is automatically out of this 2, right? T minus 2. So we have this function, and this is h of t minus tau, and this function is simply defined as x of tau. So now what happens if you find the shaded region? So this I is the shaded region. So we can say the shaded region is bounded by this 2 value, 4 and t minus 2. And what is the value of this function of triangular here? 4 minus tau. Tau is already close. So this is applicable for all this value of t which is larger than 4, and till this t minus 2 is not crossing this 4. So this is valid. It means t would be less than or equal to 6. Means if the t in the fits this equation is valid. Now we will find here what happens for convolution value. So this convolution value y of t is basically bounded by this 2 value of upper value is and the lower is t minus 2. So lower bound is t minus 2, upper bound is 4. And here if we write x of tau into h of t minus tau, t tau, so we can say between this region, this function x of tau is 4 minus tau, h of tau is 2. So then if we take the 2 as a common, so it left with 4 tau minus tau square by 2. The limit is applicable as t minus 2 to 4. So for simplicity, if we multiply 2 inside, that becomes 8 tau minus tau. And if the limits are applying as a 4 and t minus 2, so we can say first we apply 4, so 8 into 4 minus 4 square minus 8 times of t minus 2 minus plus, so that is the t minus 2 whole square. If we simplify this further, then we can say 8 minus 4 is 32 minus 16, right? And here we can get 8 16. Here we are getting t square minus 4t plus 4. The 16 will be cancelled. 32 plus 4 will be turned out as 36. this t square is there, t square is single time, so and this is the minus 12t, 40 minus 40 and minus 8t is minus 12t. Right, so this is the basically function. And if we summarize, okay, now what happens next? So if the t is larger than 6, then this function uh, is extending from 0 to 4, but this function is this function is ht minus tau is outside of this one, and no overlapping, no overlapping. And in that case, we can say y of t is equal to 0. I'm not going to plot this because the plot is complex. You can use some software like as a MATLAB, Toolbox, and other to plot this signal. But now if you summarize the thing, then we can say this y of t signal is equal to 0 for all the values of t which is less than 0. And if the value of t is between 0 to 2, then the function is a t square. Function is equal to the function is equal to the minus 2t square plus 12t minus 12 if this t lies between 2 to 4, and if this the t does lies between 4 to 6, the signals is that we already found, so that is t square minus 12t plus 36, and that is equal to 0 for all this value of t greater than 6. Okay. So that way we can solve this example. Right. Now we are going to solve the next example, and maybe probably the last example for today. And uh, if we uh, solve, if you want to solve more examples, so the two book has been given to you. One is the book is sorry, one book is the Oppenheim, and the second book is a Anand Kumar. So now we go with the next example. So in the next example, it is given that there are two signals are given, and these two signals are minus 1 to 1. This signal is x of tau, and another signal is given. This is the tau, right? And the another signal which is given here is that is 0 to 3, and this is 0. This is h of tau. So the first part is how you define x of tau. So that mathematically, if we are representing this, so we can say that x of tau is equal to the 1, is equal to 1 for all this value of tau which lies between minus 1 to 1. And otherwise it is 0, so that is 0 elsewhere. And the function h of tau is a positive going ramp starting from 0. So what is the slope? So slope can be easily identified. Vertical movement is 0 to 1, so y2 minus y1 would be a 1, right? And x2 minus x1 would be a 3. So the initial point is 0 plus the slope multiplied by tau. This is the equation. So we can easily say initial point is 0, so starting from 0, that's why initial point is 0, and the slope is y2 minus y1 divided by x2 minus x1. So vertical movement is 1, where horizontal movement is 3. So it is y2 minus y1 would be 1, and x2 minus x1 would be 3. So we can say it is nothing else but it is a 1 by 3 tau, or we may write is a tau by 3. It's a tau by 3. So this is a function, and this is valid from the value of a tau 0 to 3, and it is 0 elsewhere. This is 0 elsewhere. So first we are going to do is we will find h of minus tau. So here if you find this at this point, this is a h of minus tau. So it is actually valid like this way. This is minus 3 point, and this point is sorry, it's not like that. We have to make the signal completely like this. This is the way how you define minus 3 to 0. right? And this is tau, and this function is simply defined as h of minus tau. Uh, but you see, if we directly start the overlapping, so x of tau is basically starting from -1, and h of minus tau is lies between -3 to 0. So if we directly try to overlap, then few portions between -1 to 0 is already overlapping, right? We cannot go like that. We have to start h of minus tau with a starting point where the x of tau is starting. So x of tau is starting from -1. So first point of h of minus tau is combined with the first point of -1, and then we gradually move the h of minus tau inside and all those things, etc. So what we can say here, this is not a right starting point from where we start. So to this signal should also, this lower bound, it should be lies at this initial point of x of tau -1, so that we need to shift them in the left side. And if we shift the left side, how many points we need to shift? -1 point. So the signal becomes a -1 tau, right? The signal becomes a -1 tau. The signal becomes a -1 tau, and then after this, it becomes a like this. I think I need to redraw it. So this -1 tau is signals which is basically starting from -1, and this point is -4, right? This is the signal -1 tau, and this is simple known as h of t minus tau. So this function of tau by 3 is also going to change. It also becomes a this h of tau is equal to tau by 3, but here if you put h of t minus tau, so this function, this tau by 3 is also changing as a t minus tau by 3. So this function is also going to change, and from where we can start. So initially, if our t is less than -1, how much shifting we have applied left side? -1. So if the t is less than -1, before this we don't have a overlapping, right? So we take less than -1, we can say we have a no overlapping. This is the reason number 1 where we have no overlapping. And before this point, we can say that no overlapping, that makes the y of, it makes the sense that y of t is equal to 0. Okay, but now region 2 is the region where the t is larger, the t is larger than -1, right? Larger than -1. Okay, so in that case, if I redraw both the signals, so we can say this signals does lies from -1 to 1, right? And this signal is x of tau. And here the another signal which does lies starting from here, and this is the point of t. This is the point of t, and this is the point of t minus 3, right? This point is known as a t minus 3. This point is t minus 3 because the actual signal here, this point is t, and this is 3 point later, so it is t minus 3. The same we are reflecting over here, this is the t and t minus 3. So this overlapping region, that can be like this. And what is the function of this signal? So function of this signal is the t minus tau. This is basically h of t minus tau, so it is t minus tau by 3. This is the function of rectangular. And what is the function of this one? 1. X of tau is 1, right? So in this region, if we find the functions y of t, so y of t is bounded by this 2 point. The upper bound is t and lower bound is -1. So we can say integration limit is from -1 to t. And where this function x of tau into h of t minus tau d tau. So in this region, what happens? And this region will be sustained till either this t minus 3 enter inside, or this t will not cross this one. So which event comes first? This t will cross this one. So then the t is less than 1. So this boundary is from -1 to 1. If the t is within this region, then we can have the same boundary. Okay. Now x of tau is what? In this region, x of tau is, in this region, x of tau is a 1, and h of t minus tau is t minus tau by 3, but it's h of t minus tau, so it is tau minus t minus tau by 3. d tau. And then we take the 1 by 3 as a common, so that left with the minus 1 to t, 1 time of t minus tau d tau. 1 is not considered, so it left with the t tau minus tau square by 2. The limits are applied as a minus 1 to t, and this is a 1 by 3. So it's a 1 by 3, the tau is replaced with the t, so t square minus a t square by 2, that minus minus plus, so that is plus, and minus 1 is applied, it replaced the tau, not t, it replaced the tau. So it's a t, then minus minus again plus plus 1 half. Okay, so again 1 half is again taken as a common, so it becomes a 1/6, that becomes a 2t square minus t square plus 2t and plus 1, right? So 2t square minus t square is t square, so that becomes a 1 by 6 t square plus 2t plus 1. And this t square plus 2t plus 1, it is a very famous equation, that is 1 by 6 t plus 1 all square, and that is the y of t within the range of minus 1 to 1, right? This is the range of minus 1 to 1. Okay, now we shift the further, and when we shift the further, we can say t minus 3 require 3 point to enter inside, but this t requires only 2 point to cross this boundary. So this event comes first, and then finally the region where the t is larger than 2, this is the region number 3. In that case, what happens, the signals will remain same as a minus 1 to 1 hx of tau. And then what happens with this another signal which is uh, already crossed, this has not been entered, but this has already crossed this boundary. So that may be a t, that may be a t minus 3, and this is h of t minus tau. The function is a t minus tau by 3, it's tau by 3, and this is 1. So now what happens, what is the shaded region? If you find this is the shaded region, and which is bounded by this 2 point, sorry, it's not shaded region, sorry, right, it is a point t, this point is the point t. So what is the shaded region? Only this is shaded region, right? This is the shaded region. So this is bounded by minus 1 to 1. So if we find this y of t, then we can say that is the bounded by minus 1 to 1 and x of tau into h of t minus tau d tau. So in that region, this x of tau is 1, but h of t minus tau is a t minus tau d tau. If we take this integration, so t tau, sorry, by 3, it's by 3. So 1 by 3 is a common, so it's a t tau minus tau square by 2, and we apply the limit minus 1 and 1, that is 1 by 3. And here we can say, if we apply this limit, so 1 is applied first, 1 minus 1 half, then minus 1 is applied, so minus t and minus 1 minus minus plus, right? And okay, so this is the case, sorry, t tau minus tau square by 2, and the limits are 1. So first we apply 1, tau is replaced with 1, this is replaced with 1, this becomes a minus t tau, where it is replaced with the minus 1, so minus minus plus, and here it is replaced with the plus 1, so it is 1 half. Okay, so that becomes a this will be cancelled out, and this left with the 2t by 3 or 2 by 3t, right? Now we what is that, okay, and how much point this region will sustain? So till this t minus 3 is less than, this t minus 3 is not entering inside, so it is less than minus 1, so that is the point where t is remain less than 4, right? 3 plus 1 4, so that is the region will survive when t lies within the boundary of 1 to 4. This is the region number 3, and what we have found here, it's a 2t by 3. So now we go with the another region, that is the region number this region number next region is region number 4. So in region number 4, what happens when the t, it happens when the t is larger than 3, and in that case if we go with the same example, so we can say it is the rectangular function lies within the range of -1 to 1. Then this one is already enter, and this is already out of this one. So this is the point t, this is the point of a t minus 3, and the shaded region is this region which is bounded by this two value t minus 3 and 1. So this is our function h of t minus tau, which is simply defined as a t minus tau by 3, and this is 1. This is x of tau. So if you find here y of t, so this y of t is bounded by this two boundary. The boundary lower boundary is t minus 3, upper boundary is 1. It is x of tau into h of t minus tau d tau, and then if you apply this limit, that is t minus 3 to 1, it is 1, and h of t minus tau is t minus tau by 3, and we need to find here d tau. So if you take the 1 by 3 as a common, it left with only t minus 3 to 1 t minus tau d tau. And if we solve this further, that is the t tau minus tau square by 2, and here we apply t minus 3 to 1. So that left with 1 by 3. Tau is replaced with the 1 first. So that left with the t minus 1 by 2 minus t time of tau by 3 minus minus plus. So plus t minus 3 by square 2. Now we multiply, if we take again 1 by 2 common, so that left with 1 by 6, it becomes a 2t minus 1 minus 2t time t minus 3 plus t minus 3 whole square. Now if you solve this equation, so that is 1 by 6, 2t minus 1 minus 2t square plus 6t plus t square minus 6t plus 9. And if we solve this equation further, so we are getting here minus 2t square plus t square becomes a minus t square plus 2t, 60 will be cancelled, so plus 2t, and 9 minus 1, so it becomes a 8. So here we left with this 1 by 6. Then sorry, here we have okay, so here we give minus as a common, so it left with the t square minus 2t minus 8. Right, so this is the way how we can find. Now if the further, if you go with the next region, so in the next region, that we can say the region number 5, where we may have this exist from -1 to 1, but at the times we have already left with this outside of this one, which is h of t minus tau, and this happens when this region, okay, this region will, well, t minus 3 is crossing the boundary of 1, so it is left survive up to 4. Right? And here if this is the case when t is greater than or equal to 4, we don't have overlapping, no overlapping, and that way if there is no overlapping, then we can say this y of t signal is equal to 0. So now let's summarize what we have actually found. Then y of t is equal to 0 for t less than equal to -1. Y of t is equal to what we have earlier found is 1 by 6, right, 1 by 6 t1 t plus 1 whole square for all this value of t between 1 to 2, right, 1 to 2, and for all this value again this becomes a 2 by 3t for all these values of t between 1 uh, Sorry, that is okay. So that is here. It's a -1 to 1. That is the -1 to 1, and for all this value of 1 to 2, and for all the value of t above 2, I mean, it is the value of 2, uh, 2, 3, right? We can have it's a -1 by 6 t square minus 2t minus 8, and for all this value of this, sorry, 4, I think it may be uh, valid for the reason of what is the reason we have selected here, that is from the reason number 5 is up to 3 to 4. So yeah, so that is up to that is up to 1 to 3. That is for 1 to 3, and this is from 3 to 4, 3 to 4, and this is what we can say 0 for t greater than or equal to 4. So that you can plot by using a MATLAB toolbox, but if you plot this graph, so then finally, as per the different functions and values, then finally you are getting here this y of t is basically start from -1 and up to 4. So at this point 2, up to this point 2, it looks like is this function that cannot be easy to draw without softwares, without the use of software. So you can use this, and then it up to here it is further found like this between 2 to 4, right? So that can be valued. I think this is right. This is up to 2. Sorry, it may be from 2 to 4. You may verify it, huh? 2 to 4. Okay, so that way we can find. So this function is 1 by 6 t plus 1 whole square. This function is somewhere here to 2 by 3t, and this function is -1 by 6 t square minus 2t minus 8. So that way we can identify the signal. Okay, so now we conclude the session over here, and you just wait. I just take the presence from my laptop. You just wait for 5 more minutes. Okay, so I have already taken your presence. Now you can leave the meeting. Okay, have a nice day.
Thank you, sir.